All right, so I think we've established that I'm an idiot. But out of numbers 64 and 1.4, I have called the following information. There's a development time, that's some number t, right, of some little critter, right? So this is how long it takes the critter to go from egg to full-blown critter. Then there's some kind of development rate, that's r, which is, they're telling me 1 over t. Okay? And then there's some kind of formula. So r is b plus kh. And in this thing, they don't really tell me what b or k stand for me, but they tell me that h is some kind of temperature thing. Okay? All right, and then they ask me, according to the degree day model, there's a minimum temperature, h min, below which an organism never matures. Find a formula for h min in terms of b and k. Okay, so part A. H min is the temperature where this thing never matures. What does that mean that development time is? Right, so I'm thinking here, never matures. Good, the development time has to be infinity because it never matures, right? So I need to say it can't reach that. So if t is infinity, then I need to wonder what's r.
That's 0.
Good, r is going to be 0.
Because it's not changing. It's not
Because it never grows, right? You guys see that? Like if I'm saying it never reaches maturity, that's the same thing as saying it never has a, right? It never has a growth rate. You guys see that? It just doesn't grow. Or I could think about, okay, what happens when I take 1 and divide by really, really big numbers? Right? It gets small. If I divide 1 by an even bigger number yet, it gets even smaller. Right? And so I kind of head to 0 at least. You guys see that? So as t heads to infinity, r, I think, pretty clearly heads to 0. You can think about that as, what if we had 1 banana and we were going to split it amongst infinitely many people, right? How much bananas are everybody going to get? None, right? Cool that? Okay, so when r is 0, what's my formula for this h min thing? Good, so I go back to my model for temperature, right? And I say, okay, 0 is b plus k times h min. Then you want to solve for h min, right? So how do you do that?
We don't need to. You set it up, and we can do the arithmetic.
Yeah, you guys can do the arithmetic from here, I think.
Subtract.
So subtract. So I think some algebra 1 will get you to h min is what? You guys see it?
Negative e divided by k.
Perfect. Negative b over k. Rock star. Okay, what's part B say? B says define S as S is h minus h min times t. Okay, S is h minus h min quantity times t. Don't think I'm magicking this, I'm just literally reading it out of the book. Okay, so S is the number of degree days. That is, S is the number of days t times the number of degrees between h and h min. Use the formula r to show that S is a constant. In other words, find a formula for S that does not involve h. Your formula will involve k. Who's scared by that?
It's just too much. I have to read it a few times.
Yeah, that's okay. So read it a couple of times, and I think you'll figure out that what they want you to do is figure out what S is. Cool? I know some stuff. Right? I have a formula for R here in terms of H. And I have a formula here for H min. You guys see that? So I'm going to take those two formulas, I'm going to cram them in over there, and I'm going to find out something about S. So first things first, I know that S is, let me leave that alone, but
What?
what's minus H min?
Negative b over k.
Yeah, H min is negative B over K. So I'm going to subtract negative B over K here. And then I'm going to multiply here by T, yeah?
Isn't that the
God, that's just when I'm talking about H min.
Okay.
Right now I'm just talking about something else. What's H?
H.
R minus B divided by.
You guys all see that?
Yeah.
A little bit of algebra
yeah.
from here, right? A little bit of algebra there will get you to H is R minus B over K. So cram that in here. So I got R minus B over K. Wait, yes. What?
Just a quick question. Wouldn't you want to turn R in terms of T so then you don't have as much variables to account for?
Dude, that's a good idea. You guys see that?
1 over t for, yeah.
Yeah, we know R is 1 over T or T is 1 over R, right?
Yeah, so we were on.
So if I fiddle this around, right, I'm going to notice that some B's are going to go away, but I'm going to be left with R's and T's. But R's and T's are related by this thing. You guys see that? So which one do you want to get rid of? R or T? Your choice.
Probably
T.
easy to get rid of T at this point.
Yeah, I think it's probably easiest to get rid of T. So I'm going to swap T, right? We go, okay, what's T? T is 1 over R. You guys with me? Okay, so let me fiddle this thing around a little bit. What do I mean fiddle this thing around a little bit? What are you going to do?
Or you could put them all over one.
It's a negative.
Good. Okay, so I've got minus minus, right? I can make that into plus. They're all over K's, right?
So you can like add the terms.
So I can do R minus B plus B over K times 1 over R.
So that's just.
So minus B plus B zeroes out. So you'll get R over K times 1 over R.
R squared equals.
One over ten.
Yeah, so there's a onesie here, right?
Onesie.
A onesie.
What's that?
A multiplication by 1.
Yeah.
Right? That thing is R over R.
oh,
That's
I-
multiplication
oh,
by
yeah.
1,
I messed
which
up.
I do not need to write.
Right.
You guys see that?
Yeah.
So I can drop that part. So I find out that S in the end here is 1 over K, which is exactly what they were talking about. It's a constant, right? K is just something to do with the critter. And so what this means is that your S, right, your degree days is always constant. In other words, this K is kind of just how many degree days your critter needs to develop. You guys see that? All right, and then C says blah, lots of stuff. Okay, C says an organism requires T is 25 days to develop. Okay, I'm dumping some of this. Okay, T is 25 days. Okay, so I've got a critter that takes 25 days to develop, right? At a constant temperature of 20 degrees Celsius. Okay? And has an H min of 15 degrees Celsius. Using the fact that S is constant, how many days does it take for this organism to develop at 25 degrees Celsius? So, you guys know where they use this? How many of you guys have ever watched Bones? Or CSI? This is the bug thing. When they say, oh,
Maggots are
The-
at this stage.
yeah, this maggot or that maggot that's growing in this dead person is at this
How long
stage.
it's been.
This is how long it's been. This is how they calibrate for fluctuations in temperature.
We did this.
I feel
in
like the
school.
scientists in Jurassic Park would have used this to.
Totally. This is, yeah, everything
Except for
comes
that.
back to Jurassic Park at some level or another. Okay, so I got how many days at 25 degrees Celsius? How the heck am I going to figure that out?
Make a thing, you know, formula, kind of equation with,
Okay.
you know what I mean.
You gotta make like a ratio. Takes 25 days at this temperature. How many days at this temperature it stays?
Let's see. So degree days is constant, right? So S is 1 over K is somehow supposed to help me here. Okay, see that?
Well, K is, 1 over, no, never mind. I'm gonna shut up now. This is 1 over K. S is 1 over K,
Let's
so
see,
K is 1 over.
So I think I have two pieces of information here, right? From part A, I know something about H-min, right? What do I know from part A about H-min? Yeah, that's when R is 0. But I have some formula from,
Negative B over.
good. H-min, right, from part A is negative B over K. You guys see that? So this is one piece of information I know about B and K. What's another piece of information I know about B and K?
K is 1 over S.
Good. K is 1 over S. You guys see that? So that's one thing I could figure out. What else do I know?
K.
Or anything else? Or
And then
B?
H is
R.
H 45 minus
Yeah, so
K.
this thing I think tells me something, right? You guys see that? This guy, this whole business here, tells me what?
Takes 25 days for like.
Yeah, it takes 25 days when the temperature is 20 degrees, right? So that tells me that R, right, which is 1 over T. So 1 over 25 is B plus K times 20. You guys see this? Did I do anything crazy?
Where'd you get the
Wait,
B plus
what?
K?
Oh, it's just.
So I
That's
took
just the-
this formula, right, my original line,
That's it.
and I know that R is 1 over T.
Yeah.
So I know there's a relationship between T is 25 and H is 20 degrees. It's given by this thing. So I put in the 1 over 25 for my growth rate. And I said, okay, I don't know what B is, plus I don't know what K is, but I know H was 20 degrees for that T.
So you can figure out
You guys see that? And now I have two pieces of information. I have one equation, right, that has B's and K's in it, here. Minus B over K is 15 degrees. And I have another piece of information with B's and K's in it over here. You guys see that? So now I can solve for B and K, go back, plug in 25. You guys see that? Alternatively, I could figure out what 1 over K is using this S formula. You guys want to do it this way or that way?
First way.
First way? Okay.
The second one might be.
I'm going to do it,
Can you do it both?
yeah. Okay, I'm going to do it the first way or the second way first because it's faster and that's what the book suggested. So the book suggests that I should use the fact that S is constant to figure this out. So S is 1 over K, right? And it's also H minus H min times T. Okay, so this guy, H minus H min over T, is H, 20, right? Minus 15 times 25. And that's S, right? Which is also
1 over K.
1 over K. see that? So this is going to let me figure out what 1 over k, or what k is. So what's k? Let's see, this is 5 times 25, so I got 125 is 1 over k. Tells me k is 1 over 125, right? This s thing is constant, right? So I can go back and put in my 25. You guys see that? So I'm going to step back and do this again with h is 25. So I got 25 minus, what's 15? Or what's h, man?
I told you.
15.
Yeah.
And then I'm multiplying by t. I don't know what the t is that goes with 25.
That's what you're finding out.
Yeah, that's what I'm going to try to solve for. And this is supposed to be s, right? Which is 1 over k, which is constant. So this thing is what? What's the number that goes here? 125. Right?
It's 1 over k.
That's what s is. This is 1 over k, so I flip that over and stick it in here. You guys all playing along?
Yep.
That went a little fast.
See that middle blue equation is the same one as the very one on the bottom. The middle blue equation. That one is the same one on the bottom.
Yep. Yeah, this is s really here, right? So here I have 10, whoops, 10? Yes, 10.
Yeah.
I guess. 10t is 125, so t is what? 12.5 watts.
Days.
Days.
Cut that in half. Cut that down.
Yeah, so why did cut development time in half? So apparently, right, from this S thing, what I found out is that the only thing that matters is the number of degrees it is above the minimum times the days. Right? Like that's what it needs. So for this little bug to develop, it needs 125 degree days. Right? And so you can get 7 degree days in one of two ways, right? Or, well, in lots of ways. Two obvious ways. One is to have one day that's 7 degrees above the minimum. And the other way is to have 7 days that are 1 degree above the minimum. Okay, see that? So this thing is just telling you, this bug needs a total of 125 of those. You guys see that? And so here, it got it by having 5 degrees every day for 125, or for 25 days, gives that total 125. And here, it's getting it as 10 degrees for 12 and a half days. You guys see that? This would, of course, allow you to account for days where it fluctuated, right? Because it just needs 125 degree days. So if it was 100 degrees above this, right, we could get 100 of those in one day, and then 25 the next. You guys see that? That, of course, probably doesn't work in this model because 150 degrees centigrade will boil your bug. But whatever. Cool? Questions, things? You guys want to see it the other way? No. It's going to amount to the same thing. You're going to fiddle this around. You're going to solve for b and k. You're going to figure out k is 1 over 125. You're going to find some number for b, and you're going to do this exact same thing.
Do you think it's better than the way you just explained it?
No, they hinted at that for a reason.
Okay, then let's just follow it.
All right, and what? D. In part C, we assume that the temperature H is constant through development. If the temperature, oh, this is the shit I was just saying. If the temperature varies from day to day, the number of degree days can be accumulated until they total S, at which point the organism completes development. Yeah, this is the same thing I was just saying. Okay, so there's a table on which they are asking about maturity. So let me throw this thing up here, and we'll figure it out. So remember, we need 125 total, right? So our h-min is still 15, right? And then they give me this table. So it's day and h, right, the temperature. So on day 1, it's 20 degrees. So how many degree days do I get out of day 1? So it's 1 day, and it's how many degrees above the minimum? 5. So I get a total of 5 degree days. You guys see that? That's what this day is giving me. Okay, day 2. It's 22 degrees. So how many degree days am I getting on that day? 7, right? It's 7 degrees above the minimum. So that brings me to a total of 12. Okay, the next one is on day 3, it's 27 degrees. So how many degrees is that above the minimum? 12, and it's 1 day long, so that's going to give me 12, which brings me to a total of 24. Yeah, so these are degree day, right? And then this thing is total so far. Right, so I had 5 the first day, 12, then 24. All right, and then on day 4, it's 28 degrees.
13.
So that's going to be 13, which is going to bring me to 37, and you guys can see how this goes. You guys cool with this? Okay, the calculus thing here is that this thing, you see that? This guy here is the area underneath this thing. So if I drew this as a graph, right? Between 1 and 2, it's 5. And then between 2 and 3, it's 7. So a graph of that would look like this. 5, and then it's 7, and then it's 12 for a while, and then it's 13 for a day. You guys see that? This area under here, right? That's what these ones are. You guys see that? So calculus is really about 2 things. It's about slopes, and it's about areas under curves. And in some sense, slopes and areas under curves are related. How is kind of the punchline of the Calc 1 class. Cool? Questions, things? You guys figure out when the bug hits 125?
We could.
Okay, cool. I'll let you do that.